recording it too, so this will be on YouTube.
Okay. Well, I guess they heard me. I don't have to say it in chat.
Okay, so the audio is better. It sounds like.
Okay,
no more echo.
Good.
And now we can see Travis. It looks like.
Yeah.
All right, awesome.
Cool.
All right, so it seems like we got our technical difficulties worked out. Hopefully the audio stays intelligible and none of the cameras go out and we don't lose internet. All right, let's take. So as you can see on the screen there, with Travis, that's Travis there with the suit on. That is not the final version of the suit. The differences are really in everything. Mostly on the software side of things, we're pretty solid there. There will be some additional algorithmic changes that will happen coming up. But the version of the suit and the sensors and the hardware that he's wearing are very close to the final version. The suit itself, how it goes on, how it attaches, is much different than what you see there. We're waiting on manufacturing partners for that, but we're very close on all of the technology. It's just now a matter of getting all of the stuff manufactured, which is kind of what the holdup is right now with us getting these things shipped. And then obviously the algorithmic improvements, we can make some of those after the fact and continue to make improvements and make it better. But we have to focus on getting the hardware stable and solid, and then also focus on getting the software to the point where it's completely usable and fun and delivers on what it's supposed to do. Now, one of the things that you'll notice as Travis is playing here is that notice that he's kind of walking through that environment, but he's not moving his feet here. And the reason that is again, that we have this hybrid control methodology that we're using, where when he stands still or stops using the joystick to navigate, he can walk around very naturally, including kind of doing quicker kind of motions or crouching or things like that. But then if he wants to navigate through a larger world, when you have a finite amount of space like we have here in this area, that he can actually use the joystick on the hand controller, have that take over navigation, and then navigate a large area.
What did we do to solve the echo last time?
I turned on the microphone.
Am I being too loud, maybe? I'll talk quieter.
There's no playback here. I don't know how there's an echo.
All right.
What else are we picking it on?
Well, it seems like to have an echo, there has to be.
Yeah, it'd have to be playing at something.
Just one.
All right, I will try to talk a little quieter. I'm used to giving presentations and standing in front of crowds, so I might be talking too loudly as well, but I don't know why that would cause an echo. It seems like we'd have to have a feedback loop somewhere. Okay, so if you can still understand, I'll just continue talking. All right, so one of the things that I want to show quickly with Travis, besides that kind of hybrid control approach, go and show them the hybrid control. Switch back to the third person there. Notice that when he's standing there, he can move around, he can creep around in the environment, he can even crouch, take a knee to shoot from that kneeling position. And all of that is completely natural. But to solve the problem of having to navigate a large world that's obviously much bigger than your living room, you can't fit an entire world of zombies into your living room, or you also can't take this outside and use it, especially if you're using it with virtual reality. You need to kind of have that ability to naturally move when you need to, but then navigate a large environment. It's similar to like a game that has something along the lines of like fast travel, where you don't want to spend all your time just like walking through the game. You want to spend the time when you want to have interesting interactions, walking around and investigating. But then when you want to get somewhere else, you just want to get there, and that's the kind of thing that we actually have here. So you know, as he's walking around, it's actually doing pedestrian tracking. He can creep around, he can do stuff. If he needs to dodge something, he can. If he needs to kick things, he can. If he needs to punch things, he can. If he needs to punch things, he can. But then if he wants to move quickly through the environment, he just uses a joystick and it naturally and seamlessly takes over. And once you use that kind of hybrid control, really it's almost instantaneously understandable and usable. It's very easy to get used to that kind of control approach. So it's really just like you would when you're playing a game with on a console that you use the stick to run around. It's very natural. And we followed that same kind of methodology here. Use a stick to run around, but in our case, when you get somewhere of interest, you can then step around, you can lean around things, you can take cover, you can do whatever you want. Now, the other thing that is we've found that's very intriguing about the suit and using it, and we're not going to look at any of the virtual reality demos of it today because it's easier to see him and the screen at the same time here. But all of this stuff, you notice him switch to first-person view there quickly. And you'll notice that it does work very well for VR. We've worked a lot on getting the latency low. It might be a little bit hard to demonstrate the latency on a live stream like this. But if we go ahead and switch back to that third person, then go ahead and move your arms. And if you're watching that thing, it might be a little bit hard to see on the screen there. But and I'm not sure if the video of him through the webcam is really closely synced with the live stream. Let's take a look at that real quick and see how closely those two things are synced. So go ahead and put your arms out to your side, Travis, and then flap your arms like you're flying. It looks fairly well synced there. But if you also look closely at the screen for where he's playing, you'll notice it's very closely synced as well. And the reason for that is we've worked a lot on our end to get rid of the kind of, at least the motion control, the suit part of the latency equation. Now, the entire latency has to be the data from the sensors to wireless, to the wireless adapter that's on the host machine, in through the software pipeline, through the application pipeline, through the rendering pipeline, then to the display, and then being displayed. And our part of that, our latency part of that is with the suit that Travis is wearing now is right around 5 milliseconds. With a light suit, we're actually below 5 milliseconds. With the pro suit, we're somewhere closer to 6.5 average latency. But if you look at that in terms of the entire pipeline, that for like the graphics card to render a frame at 60 hertz, we're talking somewhere around 16 milliseconds for that. For the monitor to display the image, if you have VSync turned on, it's somewhere around 16 for that, so there's 32. So we have a very small percentage of that entire latency. But essentially what you want, though, is to have that feeling of when you move, the thing on the screen moves. And we do get that even with the rendering application latency, the rendering latency, and the display latency, that it still feels very natural and very usable. And to put that in perspective into other similar technologies or kind of motion sensing, like the Kinect is around 90, where we are with this version of the suit here, somewhere around 5. And so that's like a dramatic improvement, so that when you move, it moves with you. And so it really does feel, especially when you're in a virtual reality environment, it has that feeling of immersion that you don't want to move and then have close to 100 milliseconds later, once you count the Kinect latency plus the rendering application latency plus rendering plus display. You don't want to have that almost to a tenth of a second difference before you see something, especially when you're dealing with virtual reality, that it winds up being it breaks the illusion of immersion, where with that, us trying to get down to that lowest latency possible with the technology that we have here, while also still keeping it affordable, it really does preserve that illusion of kind of immersion, that it feels like you're in. Now, one of the things right now that breaks that illusion, this was mentioned before we actually started the live stream, and one of the chat things was like having hands that you can articulate and move and do stuff with and touch things is obviously going to be critical as well, and that is something that we've talked about and actually done some pretty I wouldn't say that we've actually designed stuff yet. We're not going to say that yet, but we have thought about that, and we have the suit that we're building now is planned to be extensible, so you can add those additional technologies that will allow additional add-ons and additional immersive components to it. All right, so one of the things that I should mention as well, before I just let Travis play here for a little bit, is that I'm sure most of you who are on here know the idea behind the suit and what we're trying to do with it, but again, it's important to iterate that since most of you, there might be one or two people on here who have actually played with one of our suits, but one of the things that's important that I should probably iterate here is the thing that makes it really exciting and fun to play is that when you normally play a game like a a console game or a PC game, you're constrained by what you can do with the input device that you have in front of you. So if that's an Xbox controller, you have a finite number of buttons, you have a few analog sticks, a D-pad, some triggers on there, and it really constrains what you can do by the input device. So if you want to do very complex interactions with that environment that you're in, you have to learn key combinations or button combinations, or you have to have a context menu that pops up that you can select things from. So it winds up being this kind of a high learning curve to be able to do complex things, but even with all of those things, you're still constrained by this finite set of things that you can do, and the developers themselves had to think up the palette of things that you could do. Where one of the exciting things about the technology that we have here is it really creates this unlimited kind of set of interactions for what you can do. So as you're walking around, and even the simple demo that we see here, it's a blast to play for hours, even though there's no real objective that we have in this demo. There's no real thing except you walk around and like kill zombies. But one of the things that makes it fun is that it's like this creative aspect to it where you can do whatever you want to, and it's not what the developer thought you should do or allows you to do. In this case, like, so if you want to kill a zombie with a headbutt, you headbutt them. If you want to throw a knee, you throw a knee. If you want to drop on the ground in the grass and aim from that, or crouch behind a tree, or lean around and take cover, you can do that. If you want to run away from something and shoot backwards over your shoulder while running away, you can do that. And that's the kind of thing that is impossible with other technologies, but it opens up this whole kind of unlimited set of things that you can do and interact with an environment. And in virtual reality, that becomes especially important because in our environment, with our bodies looking through our eyes, we are used to being able to move and do whatever we want to do. And so when you're playing something like a game or a simulation or some serious application in a virtual environment, it becomes important to be able to move naturally and have that do the kinds of things that you want to do. So notice here, as Travis is like fighting off the zombies, that he really can creatively decide what he wants to do, and including that we've had figured out all kinds of creative ways to interact with them. So, and another thing, when you deal with multiplayer games, it's even opens up the possibilities even more, because it's you doing whatever you want to do and the other players doing whatever they want to do. So it's like kind of the ultimate kind of gaming experience. And the other thing is that there's not any real learning curve other than getting used to playing without a control. And that's one of the things that we've seen when we've taken this out and had people that are, especially this is interesting, that the people who are more serious gamers have a harder time adjusting to the full body motion control than do like casual users, because we would sit down a really experienced gamer in our suit, and they would hold their hands naturally in front of them like this, like they have a controller, and they're like, how do I hit that thing? And like, well, you hit it. Just hit it. But people adapt very quickly. But like we've had children play our demos and use them that are as young as like 5, and they very naturally figure out how to use it and how to interact with it without having to learn a whole bunch of key combinations and combo moves or bring up a context menu. Now, this demo is essentially, we've been working on this for a while. The main differences that we have with the upcoming stuff is a lot of stuff behind the scenes. We've completely rewritten the API that underlies this. We've actually completely redesigned all of the embedded systems that are in this compared to previous versions. Let me take a look at some of the questions here that are going on.
Are you asking for first person? I think they want to see first person.
Okay, so let's go and switch to the first person view. That was a question that was asked. So there you can see, and you can see him take the gun and then shoot. And then you'll notice that as he does that, it is actually the camera is in the head of the player, so he can actually move. You'll notice that shakiness. That's actually him moving around and shaking to a large extent. And that's one of the things, other areas that we've worked on, is that the sensors actually are so accurate that people normally have these kind of your muscles aren't stable. That's like your body and your mind makes you feel like you are, but you're actually not stable. So one of the things that you'll notice is that the sensors are so accurate that they'll pick up all those twitches, and that's why people like Olympic shooters or competitive target shooters, they practice to time their breathing so that their muscles aren't moving. And a casual gamer might have a harder time doing that, especially after you've moved around a lot. The more you move around, the harder it is to keep your muscles still. So we've actually added into the API and into the software stream the ability to kind of tune smoothing factors so you can smooth out those motions if you need to, or if you don't want to, you can tune that so that they're not there at all. And so you'll notice right now it's cool because he's actually dual wielding. He has two pistols there, and so he could actually, if you imagine if this were, he's going to do 2 shots here at once. So he missed on the left hand. There you go. Okay, that one took a few shots, but the dual wielding, imagine that you could be playing a multiplayer game and running away and shooting behind you while shooting somebody else in front of you. Or for that matter, you could be running away and shoot both pistols behind you if there's a group of people chasing you. And so there he, let's go and switch back to third person so you can see that he's shooting both directions. So it's like completely natural and fluid for how he wants to interact with that environment. And from that first person perspective, being able to kind of look to the side and see one enemy, look in front of you, or look to the left, look to the right, and then be able to shoot both things that are coming at you. And there he just pulled a grenade off his chest. Now one of the things you'll notice about that's also possible with a suit like this is the ability to equip things in a more natural way too. That he's actually pulling those off of the chest and then actually tossing them with the hand controller, actually arming them and then tossing them. And so that's the kind of thing that, again, very naturally, like for example, having the gun at your side, he wants to grab that, he just reaches down to his side and it grabs the gun. If he wants to take the gun off his back, he just reaches back there and takes it. So you'll notice that in that main frame there, he's actually able to equip and unequip things using those positional gestures, including, notice he's switching it from side to side there. He's taking the gun in the left hand, he just dropped it into the right hand. He can help, like put it on his back on the right side like he did there. He can put it on his shoulder on the left side. And that's the kind of thing that again, that unlimited possibilities, rather than having a button that says holster weapon, and then having some kind of menu you have to cycle through to go through to other weapons or hit that D-pad to switch to other weapons. You could actually have these weapons or grenades or whatever on your body in this particular case, and you just equip them in a natural way, and that allows you to have this very fluid kind of interaction with the game too, that you're not messing with all these other extraneous buttons. You have a gun in a holster, you reach down to your side and you get it. You have one on your back, you reach up and you get it, and then you naturally interact with those things in the game. So you might ask, like, where has the work been going into all this? A lot of it has been going into those redesigns of the hardware, and a lot of people probably don't really care about what's going into the hardware, they just want it to work, and that's what we want too, is we want the stuff to work, and we want it to work really, really well, so we've put a lot of effort into getting the hardware to the point now where it's stable. One of the differences between the suit that Travis is wearing now and the final one, which I do have some of the final hardware here that I can share here in a second, this is actually one of the final hub printed circuit boards that I'm holding up here. One of the differences in this is that it actually has 6 of the chain ports rather than 5. All of our previous demos had 5, and we started out with 5, figuring you'd have, for example, one arm, another arm, a left leg, a right leg, and then the core, the torso, which is 5 total things. But we added a 6th one because it's more convenient to have the body and the head separate from the hips, and it also allows us to have ultimately more sensors if somebody wanted to make something expandable or wanted to change it around or modify the suit layout. For purposes, and it also gives us the ability to kind of divide up that traffic with more sensors like hand controllers across more ports, which is also critical for us keeping the latency down, because what's happening with all of those sensor chains, those are all communicating data simultaneously to that centralized hub that then is aggregating that and sending it wirelessly. And for us to keep that to latency down, we need to kind of make it so as much stuff is going on as possible at one time or simultaneously, and we also need to make sure we're pipelining that stuff as much as possible. So a lot of the work we've been doing is into the architecture of these things, and so we're using a more powerful processor now than is on the one he's using there in the final one. Again, the 6 chains instead of 5. We also have a different design for the onboard sensor that's on here, which is different than the ones in here. This is one of the new sensors, which I don't know if you can can see that, but we've made the size smaller yet again for the actual sensors that are going to go on the body. They're smaller than that to give a size comparison. There's a quarter, there's a sensor, and I can actually hide the sensor except for the corners completely behind that quarter. I guess the connectors on the end stick out a little bit. And really, the restricting factor for us on getting the size to be even smaller than this is the connectors themselves, that the connectors we're using to connect the wires into. There really aren't a lot of robust, kind of stable solutions for making really tiny micro-sized connectors like that. And anybody who has a cell phone that you plug into your charger knows that it falls out all the time. It doesn't really lock in, and you have to wiggle it around sometimes, and those connectors break. So we needed something that, since this is a motion suit that's going to be people doing violent things in it, people diving on the ground and rolling around, we needed something robust, something solid, something that kind of allows people to do whatever they want to do without worrying about breaking the connectors or breaking things. So that's again why these are even the size that they are. The actual components on the other side, there are a lot of components on there that are all working together here, but essentially it's the connectors that are kind of the limiting factor with the size. So he's like touching it with a jab and then taking it out with a right.
Oh yeah.
Okay, now another thing that you'll notice that as he's playing this, I kind of mentioned this earlier, is that ability to kind of fluidly do whatever you want. Besides just fighting, there are things that we've found that you can do to the zombies. Like, one of the things that we've had fun is you can, like, go up and give them a hug, which maybe would bring to mind other kinds of games that you could make with this. But we won't. Maybe we're going to get too far down that conversational path. But essentially, there he is. He gave it a hug, and then he squeezed it so hard that he killed it. And the zombies in this demo are fairly fragile. So he could actually squeeze them to death relatively easily. But you also notice that he did like a front kick to one and killed it. He could actually, can you go do a headbutt to one? Let's see a headbutt. He actually headbutted that one in the crotch, and then it fell on the other one and killed it. Oh, and back headbutt. I've actually never done that. That's actually really cool. And again, it's that creativity of being able to do whatever you want that kind of gives you that ability to think of the possibilities of what it would be like to actually play a game. There he's shooting behind his back backwards and then throwing his hand backwards. And again, that's the exciting thing to us about this technology, is the ability to do all of that stuff. All right, let me show off. I have one other thing to show off here quickly. This was that new hub design that I talked about. That is the final version now. This has actually been frozen. We're not making any more changes to this. This is the one that's going to be in the actual suits that get sent out to people. And these are so the hardware's done with this. The hardware with the sensors is done. This has been frozen as well. The hand controller, this is the hand controller hardware's done. This one is a prototype. I went and found it on the desk right before we started here. But this is one generation prior to this is the internals for the hand controller. And you'll notice that there's the trigger on the front. There's a secondary, and then there are 4 tactile switches that are below the joystick, and then there's a joystick which also has a tactile switch built into the joystick itself. And then I don't have any of the plastics for this right now. Again, those are other things that we're still waiting on third-party manufacturers to get to us. But the hardware design for all of the embedded systems, I don't have one of the wireless base station internal hardware sets here, but that's not. There's one on somebody's desk over there. But one of the things that I also, to show the size of the hub, that's going to go on the chest. It looks fairly large if I stick it up in the camera like that, but to give you a size comparison, this is like a cell phone. This is a fairly large cell phone. This is a Galaxy Note 2, but you'll notice that this is the hub. Here's the Galaxy Note 2, and you'll notice that it's really just slightly over half the height of that, and you'll notice that it's going to be about the same thickness as the Galaxy Note 2, and again, about probably 60% of the size of that. And so that's essentially what the part that's going to go on your chest is going to be like. So it's going to be fairly. That's another difference. But you'll notice in the suit that he's wearing that there's a fairly large. The hub is a little bit bulkier. It sticks out a little bit more. We're shooting for that more sleek, kind of lightweight thing. So again, it doesn't restrict your motion. It doesn't restrict if you want to, like, do any kind of physical motion in that. Now, where we are in the software pipeline, again, most of that is done. We're still making some subtle changes to that, but we've designed all of that. Like I mentioned, the hardware being extensible, the software pipeline is also extensible and allows plugins to do things like the pedestrian tracking that allows you to walk around in the environment. It also allows you to do all kinds of other things with this. One other piece of news that I should mention that we're working on is that a lot of people, our backers, are using this not just necessarily to play games like we see here, but to either make content for games or movies in the form of animations. So you want to have a mocap sequence that you record, and they want to use this as a mocap solution. We're also completely rewriting our mocap studio application. And when I say completely rewriting, we're actually completely rewriting that. And one of the motivations for that was we have a new API that is the Prio API, and we needed to make changes to that anyway to allow it to sit on top of the new API and have that kind of extensible architecture that we're talking about. So we're going ahead and rewriting and refactoring the entire mocap studio application. So any of you out there who want to use this to make your own content or make your own games, that's going to be really easy to do with the new mocap studio and get high quality animations out of that. And one interesting fact about the demo you're looking here, all the zombie animations were created using our own suit. We had Derek, who's not here right now, another one of our core developers, put on our suit and walk around like a zombie in the basement. We recorded that for all the zombie things. So if the zombies look stupid, you can blame Derek for that. But I guess zombies are supposed to look stupid, so maybe you can credit him for that. All right, so are there any other questions or things that people want explained or that are...
let's see what we have right now. I was just talking about
Okay, I know. So there was a question about the maximum range of the suit. Somebody mentioned Bluetooth. We're actually not using Bluetooth, and again, the reason we're not using Bluetooth was that kind of latency that we needed control of the entire pipeline, including the... We have other products we make that use Bluetooth, and the problem with Bluetooth is it's hard to control the entire process of getting the data transmitted and received, and including the driver side of things on the host. So we're actually using a proprietary 2.4 gigahertz spread spectrum technology, so you do have to use our, at least with this initial Kickstarter version, you do have to use our kind of wireless dongle to plug in for the communication. And the reason for that was it allows us to control every piece of the wireless communication, or really every piece of the data transfer from sensor to wireless, on air to the communication base station into the PC. We needed to control all that to keep the latency as low as possible, and that's why we're doing our own wireless solution for that Bluetooth. So back to the question about the range. The range that we're get with this in practice is really very good. We've had this at conferences, and even in our office here, we've walked the entire length of this, which is our building is over 120 feet. It's actually almost 130 feet long, and you can walk around in here. And this is a fairly wireless, a noisy wireless environment. So the range is very, very good. The range that we are calculated to get is 100 meters in practice in an office environment like this, and with the kind of antenna being right against the body, which water absorbs wireless pretty well, and the body is mostly water, so if you turn away from it. But we do get easily 100 feet and greater than that when you're line of sight with the existing solution. And so, any other questions that people are asking? Or?
I got most of the ones I saw for right now, but I'm sure more will come in a moment.
Okay.
And then there were some I missed too, because we got a lot of questions. What were you saying, Nick?
There's a question about a Blender add-on.
Oh. I think we were planning to do that at some point, but...
Okay, somebody did mention a Blender add-on. We do have one of the things I should mention is that even with our mocap studio application, you can use the data from that in Blender. You can export the data, record a mocap session into like a BVH file, and then you can import that into Blender, and you can do that like with our current mocap studio application. We had a previous mocap studio Blender plugin that worked, but Blender has changed how they do things, and so that is currently out of sync with the Prio stuff, and we haven't had time to go back and update that. That might be something we do after we get the suits out the door. Right now, we're all hands on deck getting the development done for the suits, but if there is support for that, then we will do that. And also, I should point out that with our API, the API is essentially going to be open. It's an open source API, so if anybody wants to use our API to create their own plugins or their own additional kind of abstraction layers that sit on top of that for Blender or whatever other game engine or anything else that they're doing, that's going to be completely possible. And you can look at our source code and contribute to it, or make suggestions, or even just use our API as is as a basis for making other things. And that's another thing that we've done a lot of work with that I should mention is the software side of things. The API we have has its multiple layers, and I did mention it was extensible, so we have kind of the base stream communication layer at the bottom that is the kind of PrioVR that handles all of the communication with our suits. On top of that sits the skeletal API, which allows you to, if you're a game developer, rather than having to deal with all that data yourself and manage opening the connection and have all that data stream in, our software kind of stack handles all of that and pulls it out into a complete skeleton. And then we are working on the Unity plugin that essentially allows a drop-in solution that you just drop that Unity plugin there. It talks to our skeletal API, which talks to the Prio API, which talks to the suit, and it makes it really this drop-in solution for using this. Or even if you're not using something like Unity, just having access to the skeletal API, it's essentially, it makes it very easy to, even if you're using your own OpenGL rendering engine or you're writing your own thing in DirectX, it makes it very easy to just say, hey, give me this pose of the skeleton, and then I'll apply it to my game or my simulation or my strange art kind of interactive performance piece or whatever it is that people are doing. It makes it very easy to do that at whichever abstraction layer you want. And I mentioned the skeletal API and the Prio API. Again, there are hooks in there that you can add plugins into that allow you to add additional functionality. And we've implemented our pedestrian tracking that's actually going on here in the thing. So when he stops using the joystick and walks around, that's actually a plugin that's doing that. So if somebody wants to modify that or make it work better, all they have to do is they could use ours as a basis and change that, and we're going to continue to make those changes and improvements to those kind of behind-the-scenes pieces as well. Yeah, we actually do have a virtualizer sitting over here, slightly out of shot. That courtesy the guys at Cyberith, great guys, great team, and we have been using that. We don't have a demo of that right now, but this will work with the virtualizer. And I don't know if you look at on the Cyberith Kickstarter page, they had one of their updates that showed it being used with this, and it makes it really cool because you can walk around in the environment using your legs, which I guess at least for me it was a little bit exhausting, and so I do like the hybrid joystick approach, but again, it does solve the problem of gamers sitting on their couch too much, and it is again a completely different experience than other kinds of gaming. So you can run through an environment and then interact with things or hold up a gun and shoot things, and it's completely different than using a hand controller, because again, to get immersion, you need to have your body in there. It can't just be a view into that world. You have to be able to do things and interact with things, and that's what our goal is with this and has been with this project. All right. Other questions?
Oh, yeah, questions. Let's see. I'm answering a little bit about the future plans of the company. I said we're going to look at feedback, look at improvements we can make to the suit, look at making gloves. So I don't know if you had anything else to add to that.
Yeah. Okay. So future plans of the company. Essentially, right now we're focused really strongly on getting the suits made. We have made products like high-tech products and embedded systems-based products for really the last 16 years the company has been in business. We've been doing that kind of thing. But we've tended to do things more in kind of the lower volume military aerospace and kind of industrial spaces as well, like motor controllers and robotics and things like that. But so this is kind of our first venture into that kind of higher volume, mass-produced things. And this project has things that we've never done before, like textiles with a suit. And so this has been a learning process for us. It's like it's taken us a lot longer to get those manufacturing partners in place and work with them than we ever anticipated it would. But the future plans are with this particular kind of suit itself. We're going to evaluate after we get this successful. Right now we're focused so intently on getting this to be successful. But we do have future ideas, which I'm not going to share right now, but we mentioned the gloves earlier. There are other things to make it so that that it's even easier to use in this with less kind of cumbersome stuff that you're using, and also using a hybrid of this technology with other technologies to give an even more immersive and even more kind of, I should say, natural feeling environment. And as I said, that we do have all of this does work really well with the Oculus or any other head-mounted display. We're excited to see a lot of the other head-mounted display things like the Samsung Gear, and a lot of those other technologies are coming along very nicely. And our goal has always been that to have virtual reality feel like reality, you need to have your body in there. And those other devices are doing a good job putting your eyes into that virtual world. We want to get your body in there too, because that's kind of, we're used to seeing out of our body and then touching things and doing things. You have to have your body in there to be able to do things like run around in an environment. And really, for something like gaming, it's a really, really good fit, especially for something like a first-person shooter, a game that requires movement of some sort. Even if it's not a first-person shooter, any kind of game that requires movement and things that you can do, it's really fantastic for that. All right, what else we got?
Let's see, what else do we have? Let's see, we're talking about Gear VR. There's a lot of compatibility questions. The Delta 6 gaming gun that came up a couple of times.
Yeah, I think we've talked to I think we have looked into the Delta 6 stuff and talked to them about compatibility, but I don't remember where that was.
Okay, they're asking about the stem. That's a good question.
Okay, the stem, it depends. Like, because the question was like better or worse than is PrioVR better or worse than the stem? And it depends. It's like two different kinds of technology that are doing similar things. We do have some advantages over the stem, which is a magnetic tracker that has some inertial elements in it as well. That they can do positional extraction with their magnetic technology. But the problem with that is it requires a base station that sits on the ground that you have to be within a certain distance from. Like last I checked, it was like an 8-foot radius from the thing on the ground to be there. Where in a virtual environment like this, you want to be able to move around. The other thing is that the ability to have not just that, but multiple players in the same local space together without them interfering becomes difficult with something like the stem without having multiple of those base station things. And they have a way now they can add multiple ones of those, two of those, and extend the space to a larger area and have two players. But the more trackers you get in that space, the lower the performance they have, is because it has to be divided across that thing. And there's a limit to how many trackers that they can have within that capture space. With our system here, you could very easily have somebody mentioned this earlier, like laser tag in a gymnasium. You could easily have a dozen or 2 dozen people in these suits, all occupying a very kind of small space without really having much in the way of interference between them or issues, because it's all self-contained in the one thing itself. The other, I guess some of the other advantages over the something like the stem, clearly the disadvantages are inability to have exact positioning. But one of the things you'll notice here that what matters in virtual reality, even a game like this, is that it feels natural. And so if we can get our tracking technology to be accurate and feel natural, then that's what's going to matter, because there are always going to be differences between the real world and the gaming world that are going to need to be resolved. And where STEM has a smaller number of trackers and they're using IK, inverse kinematics, to calculate the things, they're making guesses at parts of where your body are based on the position of the controllers that are in the hand. So they can extract the controller position in the hand. But again, in a VR environment, it matters what the rest of your body is doing. And if there are IK guesses wrong, then you're in a position that's different than what you would think, where we are actually tracking all of the major body segments with this suit. And this is actually, what we're seeing here is not even a pro suit. This doesn't include the foot trackers or the shoulder trackers. And so the stuff he's doing now is actually with what we call the core suit, which is essentially 5 less sensors than the pro suit that most of the Kickstarter backers went for. So the main things we can't do with this suit that you could do with the pro suit are anything like a very accurate shoulder and torso articulation, and also the feet. So standing on your tiptoes with this suit, it doesn't make any difference. So if he stands on his tiptoes here, it'll kind of look a little funny with the rest of his legs, but with the pro suit you could do that, and because it is tracking the feet and the shoulders and the hips separately, which we're not doing here. But for professional quality mocap capturing, the pro suit does a fantastic job of that. It's the equivalent of other inertial motion capture systems. All right.
Are there some of the minimum system requirements? Actually, or you can talk about the buttons on the controller. Well, what's the layout of the buttons on the controllers we're making?
The layout of the buttons on the controller, essentially, I don't know if we have the.
I can get the plastic.
Yeah. Well, if somebody grab the 3D printed version of that.
Super sweet.
All right, this is actually a mock-up of what the hand controller looks like. This is actually not functional. It would be if we put this inside of that. But for the layout of the buttons on the controller, you see we have this is not what it's going to look like. This is a 3D printer model, so it's very rough. But you'll notice the analog stick on the top, which does have a tactile switch inside that. There's the actual print site where you see me doing that. There's the stick motion there. And then four buttons that are directly underneath that, which go across there. And so it's very easy to, while you're running around, to access those buttons. And we also have a little index mark on there that you can feel with your thumb, so you can tell where the middle is. So if you're off to the side, you can still find it, kind of like the home key on a keyboard, the little bump that sticks up on the home key on a keyboard, so that you can feel, especially in a VR environment where you can't see your hand and look down at the controller and you don't want to be hunting for buttons, that lets you tactily feel where that button is. And then we have the trigger, which I'm holding this so I can see it. There's a trigger, which is an analog trigger, just like something like you're used to in a console game controller. And then we have the secondary kind of shoulder button or bumper there. And so it's very easy to use and do this stuff. The other thing that was announced about the controllers, which I don't know if everybody is aware of, is that we actually added to the controller motion sensors in the controller itself. And so not only do you have the sensor on the hand that in the suit that you see that Travis is wearing, and I don't know if can you move your hand so they can see the kind of wrist. Yeah, so you can see him moving his wrist around. But one of the things that we found out is that just having tracking the back of the hand is enough, because there are multiple ways you can hold things in your hand. You can hold something like a knife, like you're going to stab somebody. It's a different angle than if you're holding something like a sword or a lightsaber or even a gun. So the angle that you hold something in your hand can change based on the position of your fingers. And with a sensor just on the back of the hand, we decided that it was worthwhile to go ahead and add motion sensors to the controller itself. And so we've actually added 2 additional motion sensors to the suit configuration with our hand controller design. So not only does it have all of the kind of user interface analog stick, the tactile on the stick, the secondary, the analog trigger, and then the 4 tactile switches, but it also has a full motion controller, just like the other Prio motion controllers, motion sensors built in to that, so you can actually do things with the controller and have it track them, and it makes for a much more natural experience. So if imagine like a sword fighting or lightsaber demo where you want to get some kind of accurate thing or do some kind of actual thing that is more than just you could track with the back of the hand, we can now do that with the latest design.
So, someone asked about how big is the company and do we do our production in-house?
Okay, how big is the company? The YEI Corporation is, how many people do we have? I don't know, I've lost
We've
count.
got like 15 on the tech side and...
Yeah, the YEI Technology, we're a small team. We have around 15 right now on the tech side that are working on this, but also supporting some of our other like free space sensor products, which are essentially similar to motion sensor things, but for more kind of the aerospace or higher industrial applications, not gaming applications. So the technology is very similar. So we have 15 on this side, but then there's also the YI Corporation has a kind of healthcare software division. We have a network services division. Overall, we have somewhere around, 40 employees or so, I believe. But the YI Tech people working on this is a team of around 15. Now, the other, what was the other half of that question?
Oh, do we do our production in-house?
Okay, do production in-house. Actually, the production that we do in-house, we do and have done for years production of the printed circuit boards. We do all of the design, all of the production of all of the actual sensors themselves. We have a manufacturing line that is newly online. We just actually got some new quality assurance equipment, an automatic optical inspection station for that. So we can actually turn out a high volume of these, and we do it in-house, and that has given us this ability to be nimble with our designs and also be in charge of the quality of those boards that get produced by doing it all ourselves. And so we do all of the manufacturing of that in-house. The things that we are not doing in-house, obviously we're not a textile place that is used to sewing things, and so that is being done with other manufacturing partners, and also with the injection molded plastic parts we're having done elsewhere. But as far as the actual design and making of the embedded systems, that core technology, we're doing all of that in-house here with our manufacturing line. It's really cool to watch it build sensors, because we have panels of the sensors that come off of there, which maybe I should have somebody grab a panel of those that's on my desk. Like just one of those panels of sensors. But seeing the new manufacturing line being fully automated, essentially you put the panels of sensors in one machine, it puts solder paste on, and then you run it through the manufacturing line, and you get finished sensors like this that pop out the other end. And doing that in-house again gives us control of the kind of quality assurance of the core technology, which is really what matters. And then the rest of it's putting it in the plastic cases. We aren't a plastics injection molding house, so we don't specialize in that, so we're letting other people handle those things that they're good at. And we're going to handle the things that we're good at, which is making stuff like this. And doing the algorithms that back this stuff up. Yeah. Yeah, here's a panel of the actual production sensors. So you can see that here's a panel of 72 that haven't been populated yet. So essentially, we put these in one end of our manufacturing line, and then out pops a soldered version of this. It gets inspected in all the QA. We have systems that we designed that automatically program all of these, kind of a robot that programs them all, and then tests them, and then we actually have them ready for use in the suits. And then from that point, it's just a matter of putting them in cases and then having them become part of the suit. Any other questions I need to answer?
We got all the ones I saw for now.
Did somebody say it sounds like a geek company?
Someone did say that.
I'll take that. I'll take that as a compliment.
I'm sure there's some questions I missed. So if anyone has a question I missed, you can put it in again, and we'll try and answer it. We were talking about magnetic interference a moment ago, and how we have some algorithms in the works for that.
Yeah, we've been putting a lot of work into the algorithm side of things for dealing with calibration magnetic interference, since we do use magnetometers in this. And again, one of the things that we've been really focusing a lot on right now is getting the hardware stable, because we can do those algorithmic things essentially because of that extensible architecture of our API, and all of this stuff is all kind of updatable as well and designed to have additional hardware elements that can communicate with it. That we've been putting a lot of work into getting this stuff stable, and that's so we can flesh out and build all those other algorithmic things later. But we are working on all of those other things that will take it from being really, really awesome to even more really awesomer. And I see Omni support being mentioned there. Maybe Steve's answering that right now.
No.
Okay, I'll mention Omni support. We talked about the Cyberith virtualizer earlier. That we have one of those here. That we are using to test our suit with. We have used the Omni with our system as well, and it works. You have to do some things to tune the pedestrian tracking a little bit to work with the Omni, since it's kind of a bowl shape on the bottom. But it does work. The main disadvantage that we've had with playing with something like this with the Omni is the ability to, one of the advantages to this is that kind of free-form motion to be able to drop down on the ground or lie down or sit down or really crouch or do whatever you want. And some of those treadmill things kind of restrict that. So it kind of restricts the kind of game. But for something like a first-person shooter where you're doing something like Call of Duty where you're creeping around with a gun and shooting things, something like the Omni and the virtualizer, or any kind of treadmill device like that works really well. But even without those devices, just the suit itself with the hand controllers and being able to wander around in a large environment work well as well. Okay. There's some motion going on here. So
besides games, which applications would you really like to see with PrioVR?
Besides games, which applications would we like to see? Really, since we started this project, we've had so many people with so many fantastic ideas about what they want to do with it. So some of the ones that get me really excited are the ones that have kind of serious uses. I mean, besides like killing zombies and things like that, which is incredibly fun. Some of the other ones that get me excited are things that help people. So we have people using these for rehabilitation, wanting to use these for rehabilitation purposes, wanting to use them for kind of psychological things to help people get over phobias, and kind of therapy kind of uses, and also for kind of medical things for like gait analysis of people, for helping with prosthetics. We've had people wanting to do it, and I really, really love the idea of somebody benefiting from the technology that we're creating. Not that you don't get a benefit from playing a game and having a lot of fun, but I like the idea of people being able to actually have their lives improved by, in some way, by the stuff that we're creating. Really, the kinds of applications that we've seen people suggest also include things like kind of military simulation kind of training, or firefighter simulation training, to make it so that you can have first responders exposed to these virtual environments and these virtual kind of things, so they're ready if something real happens. And again, that's another thing that excites me, is the ability to keep people safe or train people better to do their job to keep people safe. And I really like those serious uses for the technology as well. But that said, playing a game is clearly something that's a blast too. So. Okay, somebody asked, can you run two suits from Pro suits from one USB controller on my computer? The answer to that is one USB controller for each suit. Actually, two of them will run on one USB controller just fine, so you could actually plug them into two USB ports. Now, maybe you mean one base station. Right now, the way we have it set up is you need a base station is associated with each suit. So you would, essentially, if you have two USB ports, you would need two USB ports, but the ports could be run off of one USB controller behind the scenes. If you only have one USB port, then I guess you could get a hub and still run two of them, and it would work just fine.
Let's see, can you talk about motion capture for film and the promised extra whatever it is for the recurring backers of the first failed campaign?
All right, I can talk about the motion capture for film, but I don't even know if I know what the the promised extra is.
Oh, yeah, I told them earlier we'd have to talk to the marketing team.
Yeah, I know that the marketing team had mentioned a bunch of stuff, but I don't want to say something and then be wrong. So I know I have a pretty good idea what it is, but I'm not going to say something and then have people be mad at me. But as far as using it for motion capture for film, again, this was mentioned a little bit earlier, but we do have it is the Prio suit. The Pro suit is the equivalent of a number of sensors and what we're sensing of a professional quality inertial mocap rig that you would see and use. And I mentioned this earlier, we have started the process of completely refactoring the Mocap Studio application. So if you want to use this for film, you can use our Mocap Studio application, record that data, and there's something else that's coming up that we haven't gotten to yet, but the ability to stream that data live using a socket layer. If you've looked at our kind of software roadmap, there's a socket server as part of that, so you could actually easily make a system that connects to that socket and then it actually allows the streaming of data live to Motion Builder or even a live action animated TV show, or for that matter, you could live stream it to a animatronic robot puppet or something like that and do kind of live control, something like that for something like film. I don't know if I answered the question or not. I said a bunch of stuff, but.
All right, here's another one. If you don't out of the box support the Omni, it would require a wireless HMD to give a real experience, right? Will you restrain your PR push to the public until a wireless HMD is consumer ready?
We actually in our lab have created a wireless Oculus using a wireless video transmitter that we had lying around in the lab. The problem there is, again, latency. When you're transmitting that much data, it has a latency associated with it, and so it becomes unnatural to do that. And so one of the things that, as far as the out-of-the-box support of the Omni, really, we can support the Omni because we don't have any wires that go from our thing to anything else, so somebody could put this on and get in an Omni and use it really without problem, as long as the game supported or the application supported our suit. It would work in the Omni just like it works in the virtualizer. I guess the other part of that question was, to get a real experience, you would need a wireless HMD. To some extent, we've done that in-house with HMD with a cable that's long enough to do that, and it does get in the way sometimes, and you wind up turning and getting tangled up in it. And that's something that to really have that full immersion without restraint, you really need either something like the Samsung Gear that's actually doesn't have wires because it's all being done in the phone itself, or you're going to need something like a wireless version of the Oculus or some other head-mounted display. There are a lot of head-mounted display projects going on right now, and clearly making that wireless is something that's going to be important and something that we can support. But we have used this in demos all over the place with the Oculus and with it tethered. And it's still, you can do a lot with it even being tethered without it being too restrictive. Especially since this would work with a light suit where you can actually still do a seated experience, like sitting in a chair like I'm in now. You can actually play with that kind of the head-mounted display connected with a wire going down to the base of the chair and still rotate around, but then run through the environment with this and still punch things in. Really, if you want to, you can wear a full suit and still do that, and then stand up when you want to and kick things and then sit back down again. But it's clearly wireless head-mounted display is going to be something that's going to be important for that fully immersive, unrestricted kind of motion that you're going to want to do with this.
Let's see. How modular is the system? Maybe you guys can add a hand glove later. Lots of people asking about that.
Yes, we talked about this really before the stream went live. We had chatted, posted a couple things about this. One of the things that we did is in this design was we made sure that we designed the hardware to be extensible, and that means that the hand controllers plugging in could be replaced with an actual hand kind of glove as well that completely tracks everything. I keep doing this. It's probably not an appropriate thing to do. But I guess there are worse things I could do. But essentially what we want is that ability to get to the point where not only can you move in the environment and have it track those motions and lie on the ground, but it's going to be really cool to be able to actually touch things the way that you do in the real world and reach out and go up to a keypad and push that with your buttons or reach out and grab something. And that's the kind of the, for us, we're focused right now on getting this completed and out there and people using it, but we've designed it to be extensible so we can add that hand controller later. The actual glove part of the controller. I shouldn't say hand controller because that means this. I should say the kind of glove controller later. And we also have, I shouldn't say we have definitive plans yet, but we have talked a lot about a next generation of this that makes it even easier to put on and removes a lot of the wires and the kind of bulk of the, and kind of hassle of having those things that interconnect things. I don't think, we don't have any other demos today, is that right?
I might get Soldier running back up again. He's recalibrating.
Oh, okay.
Is he recalibrating? Okay.
We can throw some videos up.
Yeah, so can I use my Kickstarter glove with future add-ons?
Well, we've designed to have all kinds of add-ons, and so that's where we're shooting. Is we're shooting for making this thing kind of getting it to the point where the initial release of this is something that we can then build upon to continue down the road of making this like a really high fidelity technology. Apparently we're getting the suit back up. Okay, apparently the battery was dying, so we're. I think we're almost back up live here again. Okay.
The controllers have a motion sensor inside them.
Yes. That's one of the things that we announced in the Kickstarter, but a lot of people, I think, might have missed that, is the hand controllers themselves have the same motion sensing technology in the controller itself that we have in the other parts of the suit. And then somebody mentioned like Die by the Sword, didn't they?
They did mention Die by the Sword.
Die by the Sword, and that's one of the reasons why we wanted to add those motion sensing elements to the controller itself, because it gives you this fine control over what you're doing. So you imagine having a sword fight with something like a rapier, where you need to do very fine control, including changing around your hand. There were applications where we noticed that it just felt unnatural to assume that the thing is locked in your hand like this when you're walking around, or to assume that it's in your hand like this and more of a pistol grip. That when you're using an actual tool as a human, your hand is a very flexible kind of control device and allows you to put that in all kinds of orientations. And so, since without changing the orientation of the back of your hand, you notice that I can put this in all kinds of positions without doing that. And that might be something like, even if you have a knife and you want to stab somebody, you might want to do like stab them like this, or change the angle of it a little bit. I don't know, that's maybe a bad example.
Flip the guns around or whatever.
Or a magic wand and you're making unicorns and rainbows appear. You want to be able to have fine control over that. And actually that's not a bad example, because if you want to do gesture-based things to do magic spells, you need to have that more fine control over the hand. And that's by putting motion sensors in the hand controller itself, in addition to all the other inputs, it really gives us the ability to do a lot of stuff with that we otherwise couldn't.
Let's see, assuming there's a full skeleton model in the SDK, some lip movements are difficult to model. Bending knees or elbows can end up inverted. What are the hardest movements to model?
Sounds like a question for you.
That sounds like a question for me. Well, right now our skeletal model is more of a pass-through for the data from the suit. So whatever the sensors tell the limbs that they're, like whatever orientation it says for each limb, that's the limb the skeleton, that's the orientation the skeleton will be in. We do have plans to add like constraint add-ons to the skeleton in the API, so you can stop elbows from bending backwards, strangely. But right now, whatever the suit says, that's what the skeleton API will give you.
Yeah, again, that extensible nature of the API that allows those plugins allows us to either add those constraints or add even IK, or in some cases FK for that matter. So we can add kinematics to that. But right now, as long as our sensors are accurately reporting the orientation, we're just one-to-one relaying those orientations to the avatar that's in the game. And as long as the sensors are accurately reporting that, then you wind up with something that is very natural and will, since your arm can't bend backwards the other way, and our sensors are accurately reporting the data, you're not going to have those cases where it would bend backwards, where if you have something more like something that's just getting the position of the hand and having to do kinematics to work backwards to get that. So in our case, since there are none of those constraints, if you have somebody that can bend their arm backwards, or even if they are playing the game and their elbow becomes dislocated and flops down the wrong way, we will actually track that. Sounds like the zombies are barking.
I think they can hear the zombies.
Huh?
I don't think they can hear.
Okay, the zombies are making barking noises. They sound like a dog.
I try to get the sound up.
That's fine.
Okay.
Yeah, we might need to put that in our user's manual. Have a section on safety that's like, do not bend your elbows backwards. Somebody asked if all of the animations in the demo had been recorded with the mocap suit. Yes, they have it. Like every mocap sequence in here was recorded. Actually, the zombies were recorded with a suit that was probably 3 generations ago, because we didn't redo those, right? Those are all the same ones that Derek had recorded, as far as I know. The ones that are in the game, on the zombie animations now. Yeah, those were all recorded with the suit itself.
All right, Paul, here's one. You guys must have given this a lot of thought. How do you propose developers can best handle arms, legs, or the body moving through game objects?
Okay, actually that is a very good question. How do you handle the fact that the game world doesn't exactly match the real world, and that's something that is not really easy to deal with. So the only way you can deal with it is the way that games work when you use an actual controller. So for example, when you move the analog stick in a game to move the character through an object, it doesn't stop the analog stick from moving. It still lets it move because it can't make the stick stop moving. And so that's the same thing we have here. So for example, if he walks into the side of that barn, even using his legs to walk forward, it'll kind of walk against it and stop him. So it's kind of knows it's losing sync with position from the real world. And this is one of the reasons why positioning, complete position accuracy of the sensors isn't as critical, is because you're going to lose sync with the game world anyway. And so it's going to feel a little unnatural, but what you're going to have to do is either allow it to penetrate through, or stop it in the game, and then have it so that once that kind of constraint violation has been resolved, then it goes back to following what the player is doing, so once you're not colliding anymore. And that's again up to the game developer, the game logic, to be able to do that, because unless we design a suit that can, like a full exoskeleton that stops you from moving, which is actually a really cool idea, but I don't think we can do that for a price point that people can afford. And we'd have to get this done first anyway. But it's the kind of thing that would be, it really is up to the game and how they want to handle that, the same way it is with a game that you use an actual controller for. I hope that answered the question.
FBX. We're going to support FBX.
Yes, we will have FBX support.
That was actually one of the things we were talking about right before we decided to make the new version of it.
Right.
See, he says the back to the question about moving your hand through game objects. He says that works for the full body, but what about just an arm or a leg?
Okay, the same thing with the arm or leg. Like if he runs his arm in this environment into that tree, notice it goes through that. It could just as easily have been implemented so that there's a collider on that tree and it stops the arm in the game from going through that. But the arm itself, we can't do that. And then it's up to the game logic to decide whether when you run into that tree and it stops it in game and you get to the other side, do you pop it across to the other side, or do you leave it over here and make them notice that and they have to step back so they're not colliding with the tree? Again, it's up to the game logic itself. It's up to the developer for what they want to have and what they feel is most natural in the game. And that's something that no matter whether the input device is your body or the input device is a hand controller, that has to be resolved some way. And the place where that becomes important is virtual reality, because you're going to lose that kind of feeling that you're gonna your proprioception feeling, which interestingly proprioception is why this is called the prio. That kind of proprioception that you feel like you're over here, but the thing has collided with something and it's over here in the virtual world, which is why in virtual reality probably most use cases are going to be you're going to slide through a lot of things, but then things that are important to interact with, you might actually move those around or have it stop and snap to those in some way. But again, that's up to the developer who's developing the game and their needs to be able to handle that.
Let's see. How much animation cleanup was needed for the animations for the zombies? I wasn't part of that.
There was very little cleanup that was done. Essentially, the BVHs that were recorded were imported into, I think that was Motion Builder, and then it was just from there. There was a really light cleanup done, and then it was dumped out from there. But you can see that how little cleanup is really needed, because that's a live stream right now for him going to the game and what he's doing. And we don't have any smoothing turned on right now. We do have smoothing now built in, so we could take that slider and slide it up and smooth that, and you get a much more gentle type of movement. So all of that's built into the system itself. So it's very it's designed so that you can have that smoothing and without having to have any cleanup on the data stream itself, including for a live stream, like a real-time stream like we have here. There's another question about hand sensors. Again, once we're focusing on getting this done, after that we're going to evaluate next steps, but we have talked about hand sensors. We've talked about working to reduce the bulk and the need to wire everything together in kind of that way, and also work on making it really easy to put the thing on and take off, which even more so than what we have here, which means eliminating some of the cables and things like that. So, and also things like haptics and other kinds of extensions into other feedback, sensory feedback, rather than just sensing.
So can the soldier lay down? Is that working right now?
It should be. It depends on the game code whether it has a collider there. Can you actually sit down on your butt? What happens?
Yeah, I can sit down.
Because I know we've had that working in the past, but this demo's gone through a lot of versions.
There you go. Sit down on the grass. Now lie backwards. You got guns in the way. You got to take the guns off to lie down. There you go.
You're shooting your foot, man.
You're gonna shoot your foot off. Yeah, that actually looks pretty cool right there. Now roll over.
Actually, they want you to pretend you're swimming. That's what they said.
Well, can you lie face down?
I'll get in the water.
You get in the water and swim around.
If I go walking and they'll stand me back up.
Yeah. They also wanted handstands, but we probably shouldn't try that.
Actually, that's actually another motivation for having a glove rather than a hand controller, is the ability to do handstands. And if you're like some sort of a master gymnast, then you could actually do like handsprings and backflips and things like that. But with a controller in your hand, you can't really. It also makes like crawling around on all fours, like dirt crawling, difficult because you have something in your hand. But with a glove, you could actually put your hands flat on the ground and do that.
Let's see, how resilient do you hope to achieve making the suit? Like some light bumps and thumps all the way up to whacking it with a brick.
Well, we're making it as resilient as we possibly can. We're expecting people to wear this and jump on the ground and roll around. The sensors are going to be fully cased. We've used very robust connectors for that.
It's not really swimming so much as drowning.
Looks like you're dying.
Yeah.
But back to the question about that is, I don't know if there's a good use case for having it so you could hit the sensors on your body with a brick. I don't know if we'd want to suggest that people do that because they'd probably hurt themselves. But essentially we're making it very durable. That the cases themselves for the sensors have an arched shaped top, which is very strong and very durable. And the hub itself, unlike the one that Travis is wearing in the Beta there, is very kind of slim and close to the chest, very streamlined, so it's kind of protected in the way that it's designed itself. So it's designed up front to be very robust and very durable and able to do pretty much something that would hurt you in a kind of a critical way would also critically hurt the sensors, but we don't expect people to be wearing this and actually using real swords and attacking each other, because if you take a sword to the sensors or a hammer, like a claw hammer to it, you're going to do some damage to it, but you're also going to hurt the person that's wearing it. So we've designed it to be as durable as what somebody could do with jumping around and doing normal activities that you would see in a game.
All right, someone's asking, including the controller motion sensors, how many sensors are in each suit model?
Okay, how many sensors are in each? If we include the controller ones, okay, I have to think of this here. So the core has 14, so 12 in the body, and then 1 in each hand controller. So, and each hand controller has motion sensors in it, by the way. So we have 14. The Pro suit has 19, and the light suit has not 9? I think it's 9, isn't it? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the light suit will have 10 total sensors. And one thing I should probably mention is that even with the 19 sensors all streaming at once, we're still getting very close to 200 hertz, so 200 orientations per second out of the full Pro suit that we're talking about.
They were asking how we would deal with walking around or using controllers once the gloves come out. But I said we haven't even gotten into the gloves much yet. So
well, I'll say that we have talked about that in-house and have some ideas for how the glove could be used to do that, but I'm not going to say anything right now, because then somebody will make sure that we say that we said we were going to do that. So. But it is something we have thought about.
Someone else asking about the planned shipping date. That's been a big question.
Planned shipping date is as soon as possible. Again, the big delay right now, again, all of the hardware is designed and done and finalized and ready to go. We're waiting on manufacturing partners for the plastics and the textiles for the suits, and that's where the delay is right now. We also have some supply chain logistics to work out with getting the quantities of some of the electronic components that we need. But all of that is being worked on right now. In theory, it's being worked on. Somebody's assigned to it, and we're working on all those things.
Someone wants to kill some zombies.
Lightsaber demo sounds fantastic. I like the idea of actually like a sword fighting
that'd be fantastic. I think just like a fighting game would be fantastic, where you see your opponent on the screen, you get to like duck and weave, and
it makes me wonder if that's why somebody wondered about the brick, because you have like a. We need to make a brick controller.
Do you want like the big one to be Travis?
Yeah, why don't we I guess we could swap that for a second. Okay, plans to collaborate with Omni and Cyberith. Yes, we've actually have talked to both of those, and we actually have a early release Cyberith virtualizer here that the guys at Cyberith are great guys. We've talked to them quite a bit. We've worked with them quite a bit. They have a demo up of using our suit with the virtualizer, and they sent us one of the virtualizers here for us to use in-house and play with. And so the suit does work and it gives you that experience of being able to run through an environment with actually, rather than the hand control like Travis is doing with your legs, but then still be able to crouch behind things and lean and do things. It does restrict motion a little bit, but it's still it's a different experience, and for the right kind of game or the right kind of simulation or experience, it's a really kind of different kind of play, and it's something that you can't get in any other way than having a treadmill like that.
What do you think about the resolution of the sensors?
The resolution of the sensors.
I don't think we have those numbers here in front.
We don't have those in front of us, so I don't want to quote them, but I think, Steve, you'd probably be the one who most...
I remember it being something like 0.008 degrees or something like that.
Yeah, I think that the angular resolution is something like 0.0... It's actually 0.085 degrees.
That might be right.
0.085 degrees
right.
is the resolution of the sensors. So very precise, fine movements you can actually pick up with. And I mentioned this earlier in the stream, is that actually can create problems with when you're trying to aim down a sighted weapon at a long distance. That normal people, their hands move a little bit, and the sensors are sophisticated enough to pick all of those small motions up. And so for somebody who's not a trained like target shooter, it's difficult to do that. So that's one of the reasons why we added things like the smoothing factor, so the game developer can actually add smoothing, so that somebody can aim and shoot without having to be some like trained Olympic shooting specialist.
What about OSVR?
OSVR, actually, we already have worked with the OSVR people to some extent, and I love the idea of that project, that making VR about having open standards that people shoot for, and making it about creating a entire ecosystem around things that are interchangeable and compatible. And really, I should probably also mention the ITA when I mention OSVR, that they're working towards making standards. The Interactive Technology Alliance people are working towards making sets of standards so everything can kind of interoperate. But OSVR is a great step towards having that kind of environment where there are things that are interchangeable, and we are going to support the OSVR stuff as well.
Want me to start it over?
Oh, he escaped. He got to the extraction point.
Different game modes for the zombie game.
Yeah, that's stuff that, again, we're focusing on the core technology right now, the hardware and things like that, but we're going to go back and look at adding different kinds of game modes and different things. Somebody asked if they could wear gloves under the hand sensors. Under the hand sensors. The final version that we're making right now is actually what we did is there's a kind of the glove itself has a fabric that's very flexible or expandable, and the sensor is part of that. So but it's not a full glove that goes over your entire hand. It's kind of like a fingerless glove that just comes up to the knuckles, which I don't. We had one of those, but I don't know where that is right now. And then the sensor sits in the back of that. But so you can still feel things with your palm. You can still use your fingers to touch things. So and it feels very lightweight and very comfortable, much more so than what he's wearing right now. That's much more bulky than the final version. And the I guess the other part of that question of wearing gloves underneath that, yeah, you could have. I mean, you couldn't wear winter gloves, I don't think, underneath that, but it is stretchy enough that you can get it over a very large size hand. I suppose one of it might be easier to put a glove over the sensor. The sensor won't stick up too much, but it could be worn either over or under a glove, as long as you're not dealing with some extremely bulky thing that you're wearing.
How long does it take to put on the suit?
How long does it take to put on the suit? Well, this is still one of the prototypes. The final one, the difference is, and again, we're waiting on manufacturing partners to get the textiles about this, but the final one, it actually has the two leg sensors rather than strapping on individually like you see in the frame here. It's actually more like a one-piece knee brace, or that you just like clip on. So that essentially you put that against your knee. It's got two locking clips that just clip the top one, clip the bottom one, and then pull it tight to adjust it. And really, once it's adjusted, you don't have to do that again. You pinch to have it pop back off, flip it on. So essentially, you put on the left knee, put on the right knee, put on the chest, which actually the chest comes on more like a vest piece, and it connects like this. So you put your arms in it and put it on like that, and then put on the head sensor. The arm actually. It's like a gauntlet style design. So this piece and this piece is like you slide that fingerless glove on, pull the Velcro around the wrist, and plug that in, and then you're essentially ready to go. So it's really a matter of just a couple. Whoa, what are those zombies doing?
Whoa! Oh no! Oh no!
Those zombies like that wall. They're like, yeah, get over here, wall.
Have a grenade, zombies. There we go. I got one of them out. Yeah, give me some more.
Yeah, toss that grenade down there.
There we go.
Uh-oh. Oh, you did get it in there, okay.
They're also asking if the foot sensors made a difference for walking, and I said they did.
Okay, yeah, so the foot sensors do make a difference in walking, but for a game like this where we don't have the foot sensors, you can still walk around. It's not quite as natural looking as with the foot sensors, but it is completely usable, and even in a VR environment, it doesn't feel unnatural. It doesn't, like things like, again, I mentioned this earlier, standing on your tiptoes to look over something. You notice that doesn't work here, but that does work when you add the foot sensors. Or doing something where you're like sneaking and you want to put your feet down very lightly. That's a little bit harder without the foot sensors because you need to have that toe kind of action to get that. But even without the foot sensors, it's still very usable for most kind of gaming applications. For a professional motion capture application, you would want to have the foot sensors on there, along with the shoulders and the additional torso sensor.
We use micro, no mini USB.
We're using a mini USB cord. I think the one that we're providing with it is like a standard 2 meter, 6 feet length. But you could use an extender, a USB extender, or if you want to play with it plugged in so it can charge for long periods, or if you want to. Actually, you can actually stream the data over the USB connection as well if you don't want to use it wirelessly. So you could actually tether this and stream the data over the USB connection, and actually that reduces latency even further since it eliminates the wireless portion of the latency.
How long does it take to charge?
How long does it take to charge? Essentially, it's very similar to a smartphone the charging technology we're using. It adapts to the kind of charger you're plugging into. It's like a smart charging solution. So if you plug it into a 2 amp or 2.1 amp charging station, that it'll charge at that rate. If you plug it into a regular USB port on a computer that can only source 500 milliamps, then it's going to take 4 times longer to charge. So just imagine it a lot like your standard smartphone. That however long that takes to charge, that's how long it's going to take the Prio to charge, based on what you plug it into. So if you plug it into a USB port only capable of 100 milliamps, then you're going to be waiting a long time for it to charge. But if you plug it into a 2 amp or greater capability charge port, or a dedicated charge port on a machine, then it's going to charge in probably 2-3 hours, just like your smartphone does.
Someone suggested having a battery pack on your belt connected to the suit.
That actually, you can do that with the suit right now. That's one thing that I should mention. If you want to get longer gameplay out of the thing, that since it is a micro USB port that charges it, just like you could take a cell phone and buy one of those little battery extender things that you plug in to suck juice out of that and to charge your phone while you're using it, you can do the same thing with the suit the way it is now. So you could attach one of those battery extenders to your belt, or even attach it to the if you wanted to the suit harness itself in some way, and then plug that right into that micro USB port on the suit and get I don't know, 5-10 times the battery life that we get out of it here, out of its standard. So if you're playing and you're in something really important and it gets low, you can always jack into one of those as well and pull power out of the external battery.
They're asking how it would look if he jumped. I told them we don't currently have the dynamics in there, but it would just look like he was making a jumping motion, which is not the translation.
That's a per game thing.
Yeah, that's per game. I mean, developers can do whatever they want
Well,
with the suit.
that is per game, but we are working on moving that into one of the plugins in the skeletal API as well. That's actually the research Steve is working on right now, is to add the dynamics of jumping.
Yes, I am. Yeah.
But we're not allowed yet to tell how any of that works, or even the avenue we're using to do that. But it is something that we're working on. We can say that. When I say we, I mean Steve. Well, I guess we're all a team. So.
Yeah. Trying to see if there's anything outstanding right now.
And one thing about the jumping and the dynamics is you can move very quickly in the environment. Like, Travis, can you do that? That kind of. He has to get somewhere where the ground is a little easier to do them. So you can see it does support like that kind of quick kind of movement kind of things that are like running, but jumping and leaving the ground right now, the game logic is pulling the model down onto the ground to make it hit the surface. So, for example, if he walks off that deck there, it needs to pull him down to the ground, and that's up to the physics in the game to handle that portion of it.
In the demo, if I use an Oculus, will the head sensor be needed?
If you use an Oculus, the head sensor in our suit is not needed. It actually, we have a configuration that if you're using the Oculus, you can actually use our head sensor or the one that's in the Oculus. Either way, most people will just use the one that's in the Oculus to do the head tracking. But we and then we use our sensors on the rest of the body to move the thing around. So with the Oculus plus our suit, you can get that thing where you can lean around corners and actually do the positional tracking the way that we're doing it in the game here, using our sensors to do that. But when we use it with the Oculus, we use the head tracking in the Oculus itself to eliminate having to put another thing on your head.
Yeah, David was asking about the possibility of using STEM along with our thing, but I told him that we don't know exactly how the magnetic.
Actually, we do have a hydro line around it. We have used it with that.
Did we use it along with the suit?
Yeah.
Oh, I didn't even know that. How did that work?
It works.
It works? Okay,
Yeah.
cool. All right, I guess it works.
Yeah, we have done that, and that works.
All right then. So I guess we might be able to use the STEM along with it. Okay,
well,
cool.
Assuming that the stem isn't significant, we don't have a stem line. Right?
Yeah, we always haven't had a
it's
chance
the
to try
same.
one.
It's the same underlying technology, so that it does work.
Let's see. The Oculus can provide absolute positioning. Do you use that? We don't have any hooks in our API right now to add any absolute positioning to the mix, but we'd like to get into that.
Well, the extensible nature of it would make it relatively easy to make something that solves multiple constraints like that, where it has the constraint of the position of the head that comes from the Oculus, and then have a plugin that actually uses that for something. But we haven't done that ourselves.
Yeah. See, any ideas on how to integrate this with mobile devices? Would this work with Gear VR?
Well, we don't have it working with Gear VR yet, but it is something that should be possible to integrate with mobile devices. And one of the things that we've talked about with mobile devices is that things like the Samsung phones with a USB port, that this is actually can act as a USB on the go, and so we could actually connect via wire from the suit into the actual cell phone, and then stream the data even without having to have the dongle, or we could have our wireless dongle actually plug in to the phone and then stream the suit data wirelessly to the phone. So that is something that's possible, but something that we haven't done yet. We're so focused on getting the core technology done and manufactured and out that there are a lot of these things that our plans for supporting those other things we're going to evaluate after we get everything else done.
Will we do an open web platform like Oculus did to share programs or do community stuff?
Open web platform.
I guess like having a place to share.
Yeah. That's probably something we should be planning on doing. It's like, again, we're a small team and we're focusing on getting the technology done. So that's all. Those are all fantastic ideas, and that's something that we should really talk about doing. Is having a community where people can share what they're doing using our technology, and then use that to kind of cross-pollination is really important. So using that to kind of spur further development and hooking people together, because that's where the fun stuff happens, getting different people's ideas together. And you wind up with people inspiring each other, and learning from each other, and then developing kind of new things based on the technology. So that is something that we should focus on doing. All right, somebody asked dodgeball demo. I think that we had a problem with getting it to build earlier, which I should make somebody else like explain why it didn't build, but I don't know if we have the dodgeball demo up and ready.
Well, like I said earlier, we're still in the process of moving some of our demos across to our new APIs, so some of them are in an intermediate state right now.
And somebody asked, would there be any more points on the body you would want to track, or are we satisfied with the suit as is? Now, the Pro suit is, again, pretty much equivalent to a professional inertial motion capture rig. Since the other points on the body that we want to track are obviously the hands and finger positions, and but as far as the body itself, the only other thing that's come up with some of the needs that people have is putting two sensors on the foot rather than one, since the foot can kind of have flex in the middle. And there are applications where that could be important to them. But the suit as it's designed still, the sensor chains can be extended. You could add another sensor to the foot if you really wanted to. You'd have to do some work to add our default skeleton won't work. You'd have to add additional skeletal elements to do that. Also, additional sensors on like the torso or the spine could be added. But for gaming purposes and really professional quality mocap work, the suit as it is, the Pro suit, and for mocap work works really well. We're happy with that. The core suit for most gaming applications works really well as it is. And other than for VR applications, other than needing to have hands to interact with things with some kind of glove, we're happy with the performance of the suits.
Will there be replacement sensors to buy?
Absolutely, there will be replacement sensors to buy, also additional cables to buy, and that's something that rather than having to buy it all as one set, we're going to offer those things as replacements. So if one gets broken, or if somebody wants to add an additional one to a chain, or put them on some other thing that they want to write their own custom software for, we're all for enabling people to develop what they want to develop with that, and be able to replace things if it's needed. Okay. Steve's typing this on the chat thing, but I'll mention it as well. We've got another 15 minutes here before we've got to take off. But if you have any other questions, feel free to ask, and we'll be happy to answer anything else that you guys have.
Yeah.
Maybe somebody can answer my question. Is it still echoing?
In the middle of the stream, I think David was saying it was still echoing, but I think maybe it comes and goes.
I heard it went in and out.
It goes in and out? Okay.
All right, can I use leg sensors for other things?
What are the things you you can put the sensors on whatever you want to put them on. So the leg sensors aren't really. All of the sensors are the same sensor. They're just on different parts of the body. So you can really they're interchangeable. And the way the suit knows where they are in the body is by their position in the chain for our default layout. But you can make other skeletal layouts for other things, or add props to sensors. And really, it's up to the developer how they want to use that data that comes in. So we're providing the default skeletons that match the major use cases, but we've designed the skeletal API to be kind of again extensible and modifiable and customizable. So you can say here's a a different skeleton hierarchy that I want to put in there that is maybe not even a humanoid model.
Somebody
You can
said
load that
outfit
in
your
there.
dog.
Exactly, outfit your dog, put it on your. Although we got yelled at about saying horse before.
Oh, and there we go. That's, of course.
Oh, I'm not okay. There might be a big market for that. Though, you never
We've
know.
mentioned putting sensors in other places as well.
Depends on the game.
Depends on the game, yes. That's up to the developer.
I have to point out his screen name is Smalls too, so I'm not sure what.
What else questions now? I have to get Travis over for that one, but they're asking about how accurate the throwing feels on like the grenades.
Okay, Travis could better answer that with the latest stuff. I've done some of the throwing stuff earlier, and it feels pretty accurate. But the problem that with the throwing that I had was you're holding a controller in your hand, and you, especially in VR, you look down and you see a grenade, and then you want to let go of it. So there's this tendency to want to throw the controller, which is the same as with the Wii. How accurate can you aim and throw, and how accurate does it feel? We'll get Travis over here to answer that. Get in frame there.
Am I in frame?
Yeah, you're good.
Throwing is pretty accurate, I would say. I'm not a baseball thrower, so I don't know. But most of the time, whenever I throw, when you tap the button, that's when it releases the grenade. So what I do is I aim by pointing where I want to shoot it, and then I click as soon as I do that. So it's based off the average velocity over time. So as soon as you throw it, it goes. So I don't know. I can pretty aim pretty well in demos and stuff. Underhand is really good. Overhand is really good.
Yeah, when I tried it, the only unnatural thing was the tendency to want to let go of the controller and actually throw it. And so the idea of like having to use the button to do that. But also again, that's part of the game logic as well.
Oh yeah, I imagine you're tired. Yeah, you can get some water. Oh, we got here. How many demos will be included with the suit?
Oh, how many demos will it be with the suit?
Let's see.
I'm
What all did we
a
say?
hardware guy. I don't know the answer to that.
What all did we say in the Kickstarter? I know we said the soldier demo.
We've got the soldier zombie
And
copy.
soldier.
We got like a copycat, kind of like a DDR
Yeah,
style
there's
game.
a game called Copycat where you have to get your body in different poses.
It's got like the YMCA.
Yeah,
stuff.
and that so it's very similar to something like DDR Guitar Hero, but it's like Body Hero or something where you put your body in different shapes. So that's Copycat. We have the Dodgeball. We have the Soldier demo, the one we were just looking at there with zombies, and then we also have some. I won't really necessarily call them. The wizard demo where you can actually cast spells by doing gesture-based stuff. And then we also have a really simple demo that just shows how to get the suit working and how the communication is. So rather than having the game logic and everything all in one thing, we have a project where people can load that focuses on just having an avatar and illustrating how you get the avatar to move and things. So they can take that and use that to see how, without having all of the other things going on in the code, to see kind of a stripped down demo that just shows you exactly what you need to do to get stuff done. So it's more like a tutorial than it is an actual demo, but it's a...
Let's see what else we got. Oh, and that's a good question. Have you got do we have a lanyard loop on the controller to prevent throwing them? Like on the Wii.
What we've been doing is we've been sliding the cord underneath this wrist strap, so if you do let go of it, it only falls like 3 inches.
Yeah, that's one thing that the hand controller actually, it is tethered by a cord that plugs into the hand sensor, so it already has a natural tether built in, which can unplug. So if you throw hard enough, it will unplug. But what we do and what we're going to recommend in the documentation, just like the Wii recommends, you put the lanyard around your wrist to keep that from happening. What we do is that the cord from that actually goes underneath part of the Velcro of the actual hand glove itself, so that way it's secure even if you throw it hard, and it also acts as a strain relief to keep that cord safe and from getting caught on things.
Yeah, it's tethered with cord. Yeah, he said asking if it's tethered with cord. Will the controller have mount holes to add your own straps or mounts?
No. Well, as far as I know, no. But I didn't design the hand controller either, and I haven't seen the latest plastics from that. So.
We got a close-up of the hand control.
Okay, again, this is not the final hand controller. This is a 3D printed model of it. I can give you a close-up of the hand controller internals, which, can I see the, can you turn that so I can see the frame? Yeah, this is the internals. You can see the analog stick on the top. You can see the 4 buttons here. This is hacked on here right now. This is actually one generation ago. The new ones are over there, but I don't have all the mechanicals. There's the analog trigger, and then there's the secondary button, and that goes into a thing that looks like this. So, oh, it's backwards on the screen. It's hard to look over there. So this essentially is what goes inside of that at that angle, like that. I'm bad at planning that. But the controller design looks like this. 4 tactile switches here. The analog stick with a tactile switch in the when you push it down. The secondary up here, and then the analog trigger, which you can actually use this with 2 fingers like this, or more like an Xbox where you use the index finger for both of these, and it's comfortable to use kind of in either of those configurations just by shifting it in your hand slightly. So it's about the size of like a little bit lengthwise, about the size of a Wii nunchuck, but a little bit larger. It actually feels a little more substantive than that, and then with the other things in here.
They're saying there's an extra mic on somewhere.
Isn't the laptop? Is it?
No,
I don't think it would be this.
the webcam has 2 microphones in it, and those might be desynced a little.
So the webcam is like has a stereo microphone,
And they're echoing.
Actually,
Can you switch that to mono, maybe?
maybe.
We should have thought of this earlier. I didn't know that had 2 mics.
I thought it had 2 mics in it, but I thought we only had one on or something. I don't know. I was wondering if the analog stick had a button under it.
Yes, the analog stick does have a tactile switch as part of it. So
I should know that.
Yeah, you didn't know that?
No, I should.
You should.
All right, I didn't know that. That's pretty cool.
Yeah. So there are a total of 6 tactile switches with the 4 buttons here, the one in the analog stick, and then the one on the secondary or the bumper. And then there's an analog stick that's 2 axes, and then the analog trigger. And then again, if anybody missed this earlier, the hand controller itself has essentially full motion sensing capability in that as well, which allows a whole other level of articulation that you can get out of the hand controller besides just the buttons and the other stuff you can do with it.
Say to put a piece of tape over the other mic.
I don't think they would do it very well.
Can you go to the Windows thing and just click the mono, or does it show?
I don't see a mono option anywhere.
I could take a screwdriver and stab it into one side of it.
Good. Not mine, I don't mind. Maybe that. See if it works now.
Somebody said it was amazing how we're finding out stuff from each other during the video, but it is kind of funny. Steve's like, it has a switch in it, but it's again that we're all working on our piece of this thing, and the development is going on. So like I'm finding out stuff that Steve is working on with the jumping the pedestrian track. He's finding out things about the latest or the final hardware iterations of these.
They're saying they need a full body suit where you can feel bullets. I know we saw some project.
I don't know if I want to feel bullets.
Some people.
Somebody said no, still echoing.
Oh.
Next time we'll get a webcam that doesn't have stereo mics.
I am wearing a Breaking Bad shirt. Yes, I am.
You are? See, I found something out too.
I learned all kinds of things.
That is like a crystal ball. One looking at it over.
Yeah,
I actually have seen you wear that shirt, but I had no idea that was a Breaking Bad shirt. I never paid that much attention to it.
There it is.
Good to know. Okay, somebody asked if there will ever be a point where you can feel what's in the game. I guess it depends what you mean. Feel. Again, the way that we've done the communication on this is designed to be extensible, so you can add other types of sensors or other types of modules, and we have talked about the possibility of having sensor modules that have some sort of either rumble feature or some sort of other haptics feedback in that, and so realistically you could get to the point where you can feel things in the game and somewhere have some other kind of feedback, or sensory feedback, rather than just having it output the suit be sensing things, have it also do things. And that's something that after we're done with this, we need to figure out what are the most important things that people want to see next, and what is, and once we're successful this, gauging where to go with next steps.
I know there's a lot of different groups looking into that sort of thing
Yeah.
too, and clearly it's a very complex problem to figure out.
And it's also the kind of thing that I'm not opposed at all, that the communication between the sensors and the way that we're doing that, allowing other third parties to make add-on kind of things, so they could add on, somebody else could make a third-party Rumble add-on that they plug into one of the sensor chains, and that's all it does is Rumble provides some sort of haptic feedback.
I know of someone who's working on a haptic suit to work with the Prio.
Yeah, I mean, if we had a good partner for that, we could definitely look at putting that in the Prio, but I don't know.
Hands.
Let's see. Hands. I think we might be out of time for now.
A smell generator. We actually, my dog comes to the office and is our smell generator.
Ugh.
Zeus is around here, so he's actually sleeping on the couch over there.
He's dreaming of new smells to make.
Okay, I think we're at 8 o'clock, so any other questions people have? I think, did Steve, did you post the email?
I posted our email in chat a couple of times, but I'll post it in there one more time. Any other questions you have, feel free to shoot us an email, and we'll get back to you as soon as we can.
And thanks for taking the time to listen and ask questions, and we're as soon as we're done with this, we're back to trying to get the stuff out there as fast as possible. So,
Yeah, thanks a lot. Thanks a lot for all you guys' support.
all right, thank you.